Okay, so continuing on, we're going to look at this special right triangle here. And we want to find the tangent of the 60-degree angle and then the tangent of the 30-degree angle as a ratio and a decimal. So notice here in the image, we see that this angle here is our 60-degree angle. And again, if this is our angle theta, that means when we're labeling our sides, this side here should be our opposite side, and this side here should be our adjacent side. So if we're creating the tangent of 60, we should get the square root of 3 over 1. And of course, the square root of 3 divided by 1 is just the square root of 3. And then if you go ahead and type it into your calculator, you get approximately 1.73. And then we have the tangent of 30 degrees. So in this case, our 30 degrees would be here. Okay, and that makes this now my adjacent side, and then the 1 my opposite side. So given that, once I plug in those values, the tangent of 30 degrees is equal to 1 divided by the square root of 3. But notice that I changed my final answer to that fraction because remember, and we talked about this a couple lessons ago, we cannot have a radical in our denominator. So I didn't show the steps this time, but I went ahead and I multiplied my numerator and denominator by the square root of 3 and got square root 3 over 3, which is approximately 0.58. So now when we're talking about the tangent ratio, we've only been solving for the angle theta when we're given the values of the side lengths, but it's also possible to use this tangent ratio to find a missing side length if we're just given one side length and our degree of the angle. So let's go ahead and take a look at that. So here, I am missing the side length of my base, and I'm going to go ahead and round my answer to the nearest tenth. So I'm going to go ahead looking at this problem. I'm given my theta of 32 degrees. I know from this degree here that this is my adjacent side and this is my opposite side. So I'm going to be using tangent. So I'm going to set that up as tangent of 32 degrees, because that's my theta, is equal to opposite over adjacent. My opposite is 11, my adjacent is x. I'm going to go ahead and multiply both sides by x because I want to get this x out of the denominator. And now I want to isolate x. So in order to isolate x, I need to divide both sides by the tangent of 32 degrees. And when I type it into my calculator, 11 divided by tangent of 32 degrees, I end up getting approximately 17.6. Go ahead and try this one. And again, you should have gotten, once we do this example, this is my theta, 61 degrees, equals, so this is my theta, this is my opposite, this is my adjacent, 22 divided by x. And then I'm going to go ahead and multiply both sides by x again. Then I want to isolate my x, divide both sides by tangent of 61, and I get approximately 12.2. One more, find the value of x. And then again, go ahead and check your work. This one, a little bit simpler, a little bit less steps because my opposite is my x and my adjacent is 13. So I just have to go ahead and multiply both sides by 13 in order to isolate my x, and I get 19.3. Now I'm going to go ahead and look at a word problem. So you're measuring the height of a tree. It stands 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be about 59 degrees. And now you want to figure out the height. So again, this is my theta. I want to know the height, which is opposite, and I know my adjacent. So I'm going to go ahead and use tangent, plug everything in. And then I get the height is 74.9 feet. I should have, since it said the nearest foot, rounded that to 75 feet. Go ahead and try this one. Once you sketch it out, I'm going to go ahead and create my right triangle. Here's me. I'm standing 40 inches from the base, and then my angle was 70 degrees, and I'm solving for the height. So then that means my 40 inches is my adjacent, my x is my opposite. That's what I'm solving for. If I go ahead and use tangent, I get approximately 110 inches tall that the lamppost is.